Hey everyone, I'm Kate,
And I'm Ben.
and we are representing the Biological Systems Engineering Department at Virginia Tech. And we just wanted to explain a little bit about our program and the cool things that we do.
So, Biological Systems Engineering, or BSE, is an engineering discipline that deals with engineering problems where physics, biology, and chemistry meet. As far as the type of problems that we tackle, we work with all types of biological systems, from very small things like proteins and enzymes, all the way to really large things like watersheds and wetlands. So at Virginia Tech, BSE consists of two concentration areas, environmental engineering and biotechnology. And the mission of our department is to develop and disseminate engineering knowledge that conserves the environment, as well as encourage the sustainable production, processing, and utilization of biological materials. So our program is very good if you're interested in BSE, and we rank ninth in the country. And if you're interested in graduate school, we also rank 11th.
So kind of like Ben mentioned, we have a lot of different areas that we focus in. So in biological systems engineering, there are 5 different primary areas of focus. And those can be primarily more on the watershed or environmental side, as you see at the top there, or more in the health professions, as you see in the bottom with biotechnology too, it has medical applications. And food engineering is also an up and coming field that is really cool. So for our coursework, it's going to look very similar to a lot of other engineering disciplines at first. So we have all of our intro classes for intro engineering, all of your sciences, as well as math. And then we start to get into more technical engineering theory classes where we learn more about how to apply all of these principles to biological systems specifically. You also have a lot of freedom in our program. So because of these different areas of concentration that we talked about, you have the ability to choose different classes that you want to take depending on what you're interested in. So you can tailor your courses towards a specific objective in a specific area. And that's kind of what's represented here. So all of these classes in different categories basically give you options of what to take in certain fields, and so you can choose what you want to take in order to tailor your career towards one of these specific disciplines. In addition to the actual classes, we have a lot of great labs and hands-on learning opportunities as well. So these are labs that are offered sophomore through senior year, and there are some really great experiments and facilities. We also get to go just kind of like out and see applications of these things in real life too. So the great thing about being in Blacksburg is you're being surrounded by a lot of really great natural resources and also some companies that you can go visit to see these types of practices actually in real life. So if you decide to do a career in biological systems engineering, there are a couple of different places that you could get hired. If you go more of the biotechnology food route, you could have a job at a pharmaceutical company. So someplace like Merck, Johnson & Johnson, and do mass production of biopharmaceuticals and drugs. Chemical companies in the same way, and then food processing companies. We've had a friend who did an internship at Hershey, and she loved it.
And then on the other end of things, you might find yourself working at an environmental consulting firm such as Stantec, where I interned over the summer, as well as government agencies related to the environment and agriculture like the USDA, DEQ, and EPA. And then there are also a lot of nonprofit opportunities for BSE grads, such as the Peace Corps. So as far as what we get paid, our starting salaries are between $55,000 a year and $80,000 a year, depending on where you work, who you work for, and what you're doing. And some fun facts about our department are that we have wonderful advising and it's very easy to get attention. Our advisor, Ms. Baker, does a great job looking out for us and has lots of time to help out and make sure that you're excelling academically. And our department also has a very small student to faculty ratio because we only have 191 undergraduates. And what that means is that once you're taking more specialized classes in BSE, that class size will decrease down to about 20 or 30 people in your classes. because the biotechnology type people will be doing their thing and the environmental people will be doing their thing. And another neat thing about our major is that we have a 50-50 male to female ratio compared to 80-20, which is the rest of the College of Engineering. So as far as where you can find us, we work out of Sykes Hall academically and with our environmental side of things, which is located on the drill field. And then a lot of our biotech labs and kind of advanced lab space is in Hobby.
So like Ben mentioned, in Hobby, we have a lot of research projects that are going on, and these are some examples of some of the things that we're doing. So on the nanoscale, we have engineering protein polymers and making vaccines and therapeutics, as well as biofuel production. And then more on the environmental water side of things, there's restoration of streams and wetlands and water quality and sustainability. So these are the actual facilities where these research projects take place. So they're really nice facilities. Most of these are in Hobby, so on campus. And then we also have some environmental resources as well and facilities in sites. More examples, the Food Safety and Biosensors Lab, again, is kind of up and coming, so that's really neat. The Metabolic Engineering Lab is really cool. I've gotten to do some work in there, and so really great facilities all around.
And then there are lots of outdoor research areas, such as the Stream Lab on Strubles Creek, and even as far as up in Maryland, where I did some of my research. So now we're going to answer some common questions about the program.
And we're going to go through these slides fairly quickly, but we encourage you, if possible, to pause the video and look at the slides individually. If you have any questions, feel free to let us know afterwards. So starting with biotechnology, a lot of people don't actually know what this is, and this is the field that I'm concentrating in. So when we say biotechnology, basically what we mean is using biology to produce something. So we're going to manipulate a living organism to produce a certain product at a very, very large scale. An example of this could be at Merck when you're doing mass production of a biopharmaceutical and you have a bioreactor that's 10,000 liters of bacteria all producing this one drug. So this requires a lot of knowledge of microbiology, genetic engineering, metabolic engineering, synthetic biology, and it's a really neat up and coming field that can make a lot of really cool products.
And so then another question that we often get is BSc a good fit for pre-med? Which I would say it definitely is. It might even be the best engineering option for this. And the reason is that we take 2 semesters of chemistry, the full sequence of biology, as well as microbiology, and OChem. And what all of this means is that you can get all of your MCAT requirements out of the way without actually having to add any extra credits to your curriculum. So it's really good if you want to do pre-med, pre-dental, or pre-vet.
Another common thing is BSc versus biomedical engineering. So biological systems engineering is really kind of like a broad application of biology and engineering in general. Biomedical engineering is going to apply specifically to the human body. And so you're going to be using engineering to solve problems related to medicine and to develop kind of like applications in the medical industry. Biological systems engineering, on the other hand, has certain medical applications, such as drug development, which is something that I'm interested in, but it has a lot of other different applications too. So biomedical engineering is specific to the human body, and it also has areas of overlap with other fields. So if you're primarily interested in just research, that's more of a health professions career. Mechanical engineering will give you more of a background for prosthetics. Again, BSc and Chemie for drug delivery, and then electrical engineering, computer science, and mechanical engineering for mechanical devices.
And so then another question on the environmental side of things is the difference between civil and environmental engineering and BSc. And the big difference is that civil engineers deal with site level problems. So usually the focus is preventing some human created problem from being an environmental issue when you're a civil engineer. Whereas if you're a biological systems engineer, the focus is usually on natural systems. So restoring those natural systems, or managing an entire human system like a watershed so that it encourages good health for the environmental systems. And really the big difference between us and civil engineering, you can really end up doing the same jobs after you graduate, but if you do civil engineering, you would be taking different classes like transportation, structures, and construction. Whereas in BSc, you would take more water-based classes like hydrology, water quality, and watershed management and modeling.
So for BSc and Chemie, the primary difference here is that, again, BSc is going to be very focused on biology. So there is some overlap between these two fields, but biological systems engineers are going to use cells, they're going to use plants, and they're going to use biological material primarily to make new products, whereas chemical engineers tend to just use raw chemicals and stick to traditional reactions and petroleum-based reactions as well.
And so now to answer a general question, which is the difference between BSc and biology, microbiology, or genetics. And the main difference between us, an applied engineering major, and more of a science-based major is that we focus a lot on the real-world application of all of their knowledge. So for BSc, we don't get quite as deep into the biology or microbiology or genetics as each of these respective majors, but we do apply their knowledge in the ways that are useful for solving biological problems.
Similar principles for chemistry and biochemistry. We are going to utilize the knowledge from these fields and apply them to make new products and to do engineering problems.
And then I would say the final question that we have about BSc is the difference between us and other environmental science type majors. So for us in BSc, I would say that we're most similar to environmental science compared to like natural resources or the water major at Virginia Tech. And the main difference between us and all of these majors is that we're much more focused on the design and kind of solution making of environmental problems, whereas environmental science or one of these other majors is more focused on kind of looking at these problems and monitoring them. So thank you for listening to our presentation.